All right, guys, so we're here with section 2.1, and in this section, we are starting our chapter on logic, all right? So we're going to be studying two different types of reasoning in this class. One type of reasoning is going to be today's lesson, and then the rest of it is pretty much about deductive reasoning, okay? So let's start with inductive reasoning, and I have the definitions already written out, so then you can just pause me so you can keep up. But inductive reasoning looks at several specific situations to arrive at a conjecture based off of logic, okay? So there's a key word hidden in that definition, and that's the word conjecture. And if you look further down that list of our vocabulary terms, we have it right here, all right? So we are going to be talking about what a conjecture is. But one more time, inductive reasoning looks at several specific situations to arrive at a conjecture based off of logic, okay? So let's now talk about conjecture. So we're going to skip over where it says deductive reasoning, and we're going to talk about what a conjecture is. So what a conjecture is it's a true or false reasoning based off of logic, but not based off of fact. So a conjecture is, one more time, a true or false reasoning based off of logic, but not based off of fact. So what I think is going to be the best way to explain this is actually by giving you an example, all right, of what a conjecture is. So where it says example of a conjecture, it says if we look at data over the precipitation in a city for 29 out of 30 days and see that it's been raining every single day. So our guess, all right, our job is to now guess what is going to happen on the 30th day, okay? So last 29 days, it's been raining, and we get to the 30th day, and we have to guess what's going to happen. And so what we're going to be doing is we're going to be looking at those patterns, all right, of the weather to say that, well, our guess, all right, is that it's going to rain. That's our guess. And that is based off of the pattern of what's been happening out of the last 29 days. But the thing is if we get to that 30th day, does it have to rain? And the answer is no, it doesn't have to. It could automatically just kind of be sunny, all right? Or you could get a hailstorm or have a tornado. We don't know what's going to happen on that 30th day. But what our guess is that it's going to rain. And we have that guess based off of past situations or specific situations or patterns to come up with that conclusion. So what a conjecture is it's pretty much just an educated guess, all right? So it's a guess, but it has to be based off of logic, and it's not based off of fact. So whenever it says it's true or false, that's true because it could rain, but it could also not rain, all right? And we don't know what's going to happen, but that's our guess. So to compare that, so inductive reasoning makes conjectures. Those are connected, all right? So you use inductive reasoning, you use patterns, you use specific situations to come up with a conjecture. And that conjecture can be true or false, okay? With deductive reasoning, though, all right, this one's different because deductive reasoning uses rules, definitions, theorems, and facts to come up with a true conclusion. So the main difference between inductive reasoning and deductive reasoning is that deductive reasoning, when you use that, your conclusion has to be true because it's based off of fact. Versus inductive reasoning, our conclusion can be true or false. Okay? But today all we're studying is inductive reasoning. Okay? Now, the last thing that we have here in this set is a counterexample, and we'll deal with this in a little bit. But what a counterexample is it's an example that proves a conjecture as false, all right? So a conjecture, you come up with this guess, but there might be one example that would prove it as false, all right? Okay, so let's look at example 1, and it says, find a pattern using inductive reasoning, write a rule for this pattern. So letter A says, what's the next two terms in the sequence? Explain how you reach your answer. All right, pretty simple. So what we're going to do is we're going to look to see how do we go from 3 to 6? How do we go from 6 to 9, 9 to 12, 12 to 15? And this one's pretty easy, right? All right, I could just add 3 to the 6, all right? Or I could add 3 to 3 to get 6. I could add 3 to the 6 to get 9. So I just keep adding 3s, right? So if I get to that 18 and I add 3, I would get 21. And then to get to the next one, I would add 3, and I would just add 24. Okay? And so how we reach our answer, we could just say we added 3 to the previous term. Or I can say that I'm listing consecutive multiples of 3. All right, so both of those are a pretty good way for us to write a rule for the pattern. All right, we added 3 to the previous term, or we're just listing consecutive multiples of 3. And again, that word consecutive means back to back, all right, right next to one another. All right, let's try B now. All right, so B says write the next 2 terms in the sequence. Again, explain how you reach the answer. All right, so this one's maybe not as straightforward. So if you look at 4 to 10, I would have to add 6 to get to it. And then from 10 to 8, I'd have to add, 10 to 18, I'd have to add 8. And that right there, it doesn't look very nice, right? It's not the same number. But if I keep going, I would notice that I'm adding 10, and then I'm adding 12. So what I would think to do to get to the next term is I'm going to add 14, which would give me 54. And then I would add 16 to that 54, and I would get 70 as my next term. So 54 and 70. And so the rule for this one is that I'm going to be adding the next consecutive, again, it's that same word, consecutive, even number. So I'm adding the next consecutive even number. So if you want to pause me here, all right, and try C on your own, you can. There's actually 2 ways to do this, all right? So go ahead and pause, try this one on your own, all right? Try to list those next 2 numbers in the set, and then explain how you got your answer. Okay, so I'm going to go ahead and try this one. So what you probably did was similar to what we did before, all right, where I would notice that I'd have to add 3, I would add 5, I would add 7, I would add 9, all right, so on and so forth, okay? So my next 2 terms should be 49 and 64. So one way that you could write it, write the rule, is that you're adding the next consecutive odd number. Okay, so that's one way, but I want to talk about it a different way. What else is true about 1, 4, 9, 16, 25, 36, 49, and 64? There's something that they have in common, and that's they're all perfect squares. So the next thing that you could do, you could write here, is that you're listing consecutive perfect squares. Okay. All right, so what I'm going to do is I'm going to pause here, and then we are going to try something new for the next video.